Thanks for coming. I'm Masa, the friendly developer from the Treasure Data. In this session, I talk about the friendly basis for the new friendly users. So I talk about the architecture overview and the practice and the use cases with Kubernetes. Okay. First is a friendly overview. Okay. This is a list of the what's the friendly. The friendly is designed for the streaming data collection. So friendly is continuing to the read from the data and send to the data to the destination in the streaming manner. So unlike a batch model, so friendly is friendly focuses for the low latency log transfer. The friendly is using the Ruby gems for the plugin development and distribution. The Ruby gems is a standard platform on the Ruby. So friendly uses Ruby whole Ruby ecosystem on the plugin development. So we can use the Ruby any Ruby library to develop the plugin, and easy to distribute in the Ruby gems. So we can easy to write the plugin and easy to reuse the plugin on your environment. And the friendly provides several approaches for the setup. So you can use the RPM or dev for the CentOS or Ubuntu or Debian. And the friendly community also provides the MSI packages for the Windows. So you can run friendly on the Linux and the Windows. And friendly is a logging part of the CNCF. So friendly is used in the Kubernetes, and friendly also uses a CNCF product. For example, friendly has a Prometheus plugin to export the friendly metrics to the Prometheus. So you can monitor the friendly instances using the Prometheus. Okay. This is one example of the friendly's log collection. So this example is for the local files. So we friendly monitor the local files, and if application writes the logs to the local files, friendly reads the data immediately and send to the logs to the central server with low latency. So you can check the logs on the local server quickly. So this is good for the data log processing, because you can use the Spark or other data processing framework with the newer logs. So you don't need to wait the log rotation or the file complete. And I said friendly has a plugin, so you can use the plugin to the for any destinations and any data sources. So you can read the data from the any data sources, and you can send the data to the any destination. So no need to write the your own script for your needs. So friendly is a glue in your data pipeline. The next topic is friendly architecture. So I will show how friendly works. Okay. This is details of the friendly design. Friendly consists of the core parts and the plugin parts. And the friendly core covers the common concerns of the data collection. So friendly core provides the buffering and restoring feature, and the error handling for the temporal failure or the unrecoverable errors. Of course, friendly has the event routing for the data destinations. Friendly has more features for the parallelism for the data, improve the performance. And the friendly core also provides the collection of the plugin helper for plugin development. And the plugin paths is the interface of the real use cases. So friendly core provides lots of good features for the data collection. So plugins focuses on the logic of the real use cases for write to the databases or read data from the API, HTTP API, or how to pass the data or how to format the data. The API is very simple, so developer easy to write the new plugin for your requirements. And the next is this is Fluentd's event structure. So for example, Apache logs. If you have Apache logs, one Apache log line is converted into this data structure. So time and the tag are the records. The tag is identifying data sources, so you can use this tag for the where this data comes from. This tag is used for the event routing in the Fluentd's pipeline. The important point is a record. Record is actual log content, but format is a JSON object, not raw string. Because recently, many middlewares or data services can accept the JSON format natively, and the JSON object is easy to mutate or easy to format to the other format. So instead of raw string, JSON is very good for the recent systems. So this is why Fluentd uses JSON object, not raw string. This image shows the data pipeline in the Fluentd instances. So incoming events are passed through this right to left. So input plugin, filter plugin, buffer plugin, output plugin. Now I talk about each component. The input plugin. So this is the third point of the Fluentd data pipeline. So input plugin receives the data from the HTTP or read data from the local files. So receive the data, emit the data to this pipeline. So the important point is this HTTP plugin passes the data for the structured logging. So I said that this event. So input plugin converts the raw string or binary data to this format. Next is the filter plugin. So filter plugin is very simple. So mutating the record or filter out the logs. So for example, adding the host name to the event record or filter out the unnecessary logs with conditions. For example, info level or error level or something. And of course, filter plugins could be chained. So you can apply the multiple filters as one data streams. Next is the buffer plugin. The buffer plugin is not a standard plugin. This plugin is used inside the output plugin. So buffer plugin is used for the stored events before data flash. So this is important for the improved performance. For example, some output plugin is not optimized for the small request. For example, MongoDB or Elasticsearch. It needs a bulk import for the data ingestion. So buffer plugin is collecting the data, merges the small records into the one large chunks. So the output plugin uses these chunks for the data flash. So this is why buffer plugin is important for the Fluentd. And the Fluentd provides a buffer plugin by default. And this buffer file plugin stores the data on the persistent disk. So this avoids the data loss when the Fluentd crash. So we recommend to use the file buffer on the production environment. The output plugin is very simple because buffer plugins manage the data streams and how to manage the data chunks. So output plugin, very simple, is a write to data to the destination. So MongoDB, Hadoop, or other cloud services. This is a real example of the input plugin. So Fluentd can consume the data from the Kafka or can collect the data from the HTTP endpoint. The out of plugin is community has lots of out of the plugins because lots of destinations, so MongoDB or Prometheus, Elasticsearch, Kafka, or more. Okay, and the next is use cases with the configuration. So I will show the use cases and the actual configuration for how Fluentd use. This is very simple forwarding configuration use cases. So this is collecting data from the local files and receiving data from the application and send data to the MongoDB. This is a configuration example. So source section is for the input plugin, and the match section is for the output plugin. So in this case, we use the tail input plugin and the forward input plugin. And the match section has a tag pattern. This is a app prefix tag pattern. So in this case, so if tag matches this pattern, these events are stored into the match section. So in this case, tail input plugin's data is stored into the MongoDB. So you can specify a complex data pattern. So you can build the complex data routine with tag matching. Next is the multiple destination. Sometimes we want to send the data to the multiple data stores. So Fluentd also supports these use cases. And for these use cases, we use the copy plugin. So we can wrap the output plugins with the copy plugin. In this case, front side. So if this configuration app tag prefix patterns data is stored into the Elasticsearch and the HDFS at the same time. So if you want to add more destinations, you can just add the store sections in the copy plugins. And Fluentd also supports the multi-tier forwarding. This is mainly for the high traffic environment, so you have lots of forwarders and the data traffic is high. So Fluentd has their own forwarding protocol with the forward plugins. So this shows the Fluentd forward protocol supports the two delivery semantics, at most ones and at least ones. And forward protocol also supports the high availability and the load balancing. And the recent version has also keep alive. So you can use this forward protocol covers the high traffic environment with high availability. This model has pros and cons, and how to explain this complex model in this session. So if you are interested in this model, please check the previous talk at the KubeCon. So we have forward side aggregator or aggregator side, and sometimes several approaches in this model. And next is talk about the container and Kubernetes. So Fluentd is widely used in the container environment. For example, so by the Datadog research, Fluentd is a fourth product on the running on Docker. So Fluentd is used in the collecting the logs on the Docker environment. In this chapter, so I will talk about how to collect logs from the container environment. Okay. Before talk about the collecting, so I talk about the resources for the container environment. You can use the Fluentd with these setup. So one is the Docker and the Kubernetes and the Helm chart. Fluentd community provides the Docker plain Docker images in the Alpine and Debian. This Docker image is Docker official images, so you can run this container on the ARM or PowerPC or more platforms. So if you are using plain Docker, so not Kubernetes, you can use these images for your environment. And on Kubernetes, Fluentd provides a Kubernetes demo set, setting and the Docker images. And this images has several built-in destinations, so Kafka or Elasticsearch. And of course, you can easy to use your destination with these images. And I'm not sure, but the Helm chart provides the Fluentd images as a stable version. So you can, if you use the Helm, you can also use this Helm chart images on your environment. Okay. Next is how to collect data from the Docker environments. So this is Docker specific approaches. So Docker logging with the logging driver. So Docker has a logging driver mechanism to send data to the external systems. So for example, local file or the TCP over TCP. And the Docker logging driver supports the Fluentd logging driver by default. So you can easy to use. You can easy to collect Docker logs with the Fluentd with this logging driver. This logging driver collects the standard out, standard error data from the container instances and send it to the Fluentd with the client library. So if you set the forward input plugins in Fluentd side, you can collect the data from this logging driver. This is Docker specific environment. This is Docker specific approach. So if you use the plain Docker environments, you can use these approaches. This approach can't use on the Kubernetes or other environment. The second approach is using Fluent Logger. Fluent Logger is a client library for each language. So Ruby has a Fluent Logger, Rust has a Fluent Logger. So this approach is you need to add the logging code in your application, but you can use any data format or any data with this client library. So no need to parse or something. So this is same as the Fluentd logging driver. You can use the forward input in the Fluentd instances. You can collect data from this client library. So this made is so you can collect any data in your application. Okay. Third approach is using the shared data volume. Sometimes we can't change the logging setting of the container images. For example, middleware uses only local files. For this use cases, we can use the shared data volume and the input tail plugin to collect local files from the containers. And on Kubernetes, we use the similar approaches to collect data from the container instances because Kubernetes send container instance data to the Barlog containers directory, and no need to access to the container standard error or standard out. So we need to use the Tailwind plugin and the plugin to collect data from the container logs on the Kubernetes environment. So our Kubernetes demo set images uses this setting on the collecting the all Kubernetes container logs and send the data to the Kafka or something. But our Kubernetes demo set images has the additional additional data to the data logs, because on Kubernetes we sometimes want to metadata for the namespaces or container name or pod names. So we added the Kubernetes metadata filter in the Fluentd data pipeline to gather Kubernetes data and add this metadata into the data streams. So if by default, so log data is very simple. So log field has the actual logs. But after applying this filter, the log has more metadata for the Kubernetes. So this is the example of the container name or namespace. So you can use this metadata on the processing side, so grouping the containers logs or something. So this is a summary of the container logging. So we can I show the 4 approaches. So Docker specific approaches or general approaches with the client library, and use the shared volume for the non-customized images. And on Kubernetes environments, we can use the metadata to the more rich data processing. So you can choose these approaches for your needs. This is the last chapter, so I introduced the Fluent Bit. Fluent Bit is an important ecosystem on the Fluentd. So this is a comparison table of the Fluent Bit and the Fluentd. So Fluentd is written in Ruby plus C, but the Fluent Bit is fully written in C. So this is a very small application. So if you want to reduce the memory or CPU usage, you can consider the Fluent Bit instead of the Fluentd. The Fluent Bit design is very similar to the Fluentd. So Fluent Bit event also has a tag and time and record, and the Fluent Bit also has a router, event router for the tag-based routing. So you can use the Fluentd knowledge for the Fluent Bit. The Fluent Bit also uses a similar approach, the same approach in the Kubernetes environment. So you can also use the get the Kubernetes metadata in the data pipeline. So you can use the Fluent Bit on the forwarder side instead of Fluentd to reduce the resource usage. Currently, their pattern is very popular, so some users deploy the Fluent Bit on the Docker's forwarder side and set up the aggregators for collecting the thousand nodes from the aggregator and send it to the destinations. So you can get the Fluent Bit's merit and Fluentd merit in this combination. And the latest Fluent Bit has a stream processing feature in the core, so you can aggregate or some more complex calculation on the forwarder side. So this reduces the network traffic or more in the forwarder side. And if you are interested in this stream processing on the edge, please check the Fluent Bit documentation of the stream processing article. Okay, enjoy logging. Thanks. Any question? Okay. Oops.
So, is it possible to use the Java language to write a plugin for Fluentd?
Java language plugin?
Yeah.
So you want to write the Java language?
Yes, maybe just Java is an example. What else language is supported to write a plugin for Fluentd?
So what you want to collect the Java application logs?
Actually, I mean, you just talk about the plugins, right?
Mm-hmm.
There could be a lot of plugins. So what kind of languages are supported to write a plugin?
So Java-based plugin?
Yeah.
Currently only Ruby.
Okay, only
Ruby.
Oh, only Ruby.
Yeah.
Okay, got it. Thank you.
So one actually, so Fluent Bit is written in C. So Fluent Bit is we can write the plugin as a C language, but Fluent Bit supports the Go language as a plugin. So maybe we can friendly we can similar approach to the using the other languages to the plugin language. This is the future work. Okay. Other question?
Hello. I want to know how Fluentd to handle the log from the standout
Standout?
Yeah.
So you mean the
for example, my application just write a log like a printf, and then how my Fluentd to collect the log from the from the standout. Yeah. I just.
so this is on the container on the container or bare metal?
Yeah, it's just something like I run the command kubectl to get the logs the port, and I will find the log message, right? And how can I import the log message into Fluentd? Yeah.
So if you use so Fluentd has a standard out input plugin in the input side. So if you send the log to pipe to the Fluentd, so you can use this plugin. But if you use run the application on the container or Kubernetes, so you can use this approach. So Kubernetes send logs to the borrowed container, so you can use the input plugin. Or if you use the plain Docker, you can use the logging driver to the container.
Okay, thank you.
Is there any plan about open telemetry?
Open telemetry, yeah. I am considering the support for the open telemetry, but open telemetry is I'm not sure the progress of the migration from the to a project. So if you finish this migration, and if we or public the open telemetry Ruby library, so we can easily support this via the plugin. Yeah. Okay.
I have a question that in the logging system, sometimes we need some buffer. For example, Kafka to slow down the stream, data stream, and in this architecture, then Fluentd can be there is an aggregator in Fluentd. Can this aggregator act as a Kafka role in the whole system?
Yeah,
since there is a buffer.
So you can use the Fluentd instead of the Kafka on the global buffer, like data pipelines buffer. Maybe I think the Kafka was as a product is better than the Fluentd because Kafka has replicates the data to the distributed clusters, but Fluentd it doesn't support this model. So if one instance is the crashes and how do they HDD or ICD the crash is so hard to recover from the data. So Fluentd's aggregator is mainly for the collecting the data from the forwarders and merge the data streams into the one and send it to the destination. So we recommend to put the aggregator on the before Kafka, because for example, one customer uses Fluentd and the Kafka combination, but the forwarder is very the large number of forwarders. So sometimes Kafka is down because by the high workload. And this one customer set up the aggregators before the Kafka, so Kafka becomes stable. So if you want to use the global queue as a Kafka or as a product is better, but aggregator helps the stable operation for Kafka.
Okay.
Yeah.
So one question about the metadata or the workload on Kubernetes. So your PPT, your slides just mentioned we can append some metadata to the log.
Okay.
So for the workload, so this kind of appending could be done automatically, or we need to do it with the code.
What? This one?
No. There's a slide about the metadata.
Metadata?
Yes, on the Kubernetes workload.
No?
Oh yeah, right.
Yeah.
Yes. So yeah, you can see you append the namespace and the container name. So just mention this kind of metadata we should maybe we need to append to the log, right?
Yeah.
Yeah. So can be done automatically, or we need code something.
This how to collect this metadata?
Right.
Yeah, this is calling the API server, Kubernetes API server, periodically. So updating the metadata from the Kubernetes API server, if adding the data from this data.
So what you said, the Fluentd will talk to the API server,
Yeah.
and append the metadata into the logs,
Yeah.
automatically.
Automatically.
Okay. Thank you.
First off, thank you for the talk. Secondly, I have a question. So, compared with other competitors, why should I choose Fluentd? Yeah, in general, just wrongly.
What's the company?
Sorry? Other competitors like Logstash or yeah.
This is depends on your needs. So Logstash is depends on Java. So this is sometimes JVM is a very large on the container environment or something. And this is maybe if you are specialist of the Java or JVM, and if you want to the connecting to the Elasticsearch, maybe you can use sometimes Logstash is better.
Okay.
Yeah, but Fluentd is the general log collection. So many users use the Elasticsearch or Kafka or S3 or more other cloud environment. So Fluentd has lots of plugins, so you can easily connect to the other systems. So this is you choose which is better on the your workloads. Maybe very feature is very similar to the recent log collectors.
Okay. Thank you.
Sorry, one question about Fluent Bit.
Yeah.
Does Fluent Bit have some solution for log data with different priority, especially when the output bandwidth was very limited?
Priority means band-wise or something.
For example, we have two different data sources for input, and they have different priority. Then when the output bandwidth was very limited, we want the data with higher priority was sent first.
So you want to, if you have two data sources and one is high priority, you want to process the data high priority is first. Currently maybe no.
Okay.
If you have a good idea, so please post it on the pull request.
Thank you.
Okay, thank you.